Okay, today we're going to take a look at infinite limits. I know it sounds scary, don't worry, it won't be too bad. So let's go ahead and start. Students will be able to understand what an infinite limit is. And my goal is a little bit further. I'm going to stretch that to also know how to solve them. So let's go ahead and let's read the first little bit. A limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. Basically, in English, if you look at your height at a certain location and it's reaching infinity or negative infinity, you have an infinite limit. So I took the liberty to graph this function already for you. So the function is 2x plus 1 over x minus 3. Now, if you recall from Algebra 2, the denominator is how we can predict a vertical asymptote. And so basically, if we find the excluded value, if we take the denominator, set it equal to 0, and solve, so I'll add 3 here to both sides, x is equal to 3, which really means x may not equal 3 because that's what makes 0 in the denominator. That's where we have, in this case, a vertical asymptote. So just a little refresher. It says, please note a non-zero number divided by 0 indicates the presence of a vertical asymptote. We just showed that algebraically. So let me scroll down to example 1. It says, use the graph to see what is occurring at x equals 2. Now, if you notice, if I put a 2 in here for the denominator, or if I set the denominator equal to 0, I can solve, and I know that I have a vertical asymptote at 2. Okay, so limit as x approaches 2 from the left of our function. Now, I'm going to pick my trusty yellow highlighter, and if I'm approaching from the left, I'm going to hop onto this graph and I'm going to highlight where I'm going. Now notice that I'm getting closer and closer and closer and closer to negative infinity. So that would be negative infinity. In terms of approaching from the right, let me grab my trusty highlighter again. If I follow the graph and I get closer to 2, notice that you're going to positive infinity. Those are infinite limits. Very easy. Now, what can we say about the general limit? Therefore, the general limit does not exist because I'm reaching negative infinity from the left and I'm reaching positive infinity from the right. And remember, for the general limit to exist, the left and right have to be the same heights. Okay, example 2. It says determine the limit of each function as x approaches 1 from the left and from the right. Okay, no worries, we can do this. Now remember, the reason why we're approaching 1 is that's where our vertical asymptote is. If I plug in a 1 for x, I end up getting 1 over 0 at that location. So let's go ahead and let's write our nice basic limit notation. Limit as x approaches 1 from the left. And then because they gave us f of x, I'm just going to take the shorthand notation and write f of x. You could either do this or you can write it as limit as x approaches 1 from the left of 1 over x minus 1. Either way is fine. Okay, so if I grab my blue highlighter here and I jump on this curve, I notice that just like before, I am approaching negative infinity. So this would be equal to negative infinity. If I'm looking at the right-handed limit, limit as x approaches 1 from the right of f of x. Let me grab my blue highlighter again. If I'm approaching from the right-hand side, it looks like my height's going to be positive infinity. And now for the general limit, even though they don't want it, they didn't ask for it at least. Limit as x approaches 1 of f of x is equal to, okay, in terms of this, because I'm approaching from the left and I get negative infinity, approaching from the right and I get positive infinity, that means the general limit does not exist because they don't match. Alright, I hope you're getting the hang of this. It's not too bad. It's all about looking at the sketch. And like I said, the graphical method is my favorite. So, okay, this is a very interesting one. It says determine the limit of each function as x approaches 1 from the left and from the right. Now the reason why this is interesting is in a few videos ago I kind of sketched something similar. And let's go ahead and see what happens here. So if I want from the left-hand side, let me grab a red marker here. Limit as x approaches 1 from the left of, and I won't get lazy here, I'll even write out the whole function. The only reason why I wouldn't write out the whole function is on a test you might write the function incorrectly. So if they give you a name for the function like f of x, it's kind of easier, it saves you time, and also you won't make a mistake in rewriting the actual function. Anyways, if I'm approaching from the left, I notice here that I get positive infinity for my height. And you're not going to really cross that asymptote. My highlighter gets a little wacky sometimes. So you get positive infinity. If I'm approaching from the right, limit as x approaches 1 from the right of 1 over x minus 1 quantity squared. Let's see what happens here. Let me grab my trusty highlighter. Now notice I'm also approaching positive infinity. Now if you wanted to say that, hey, the general limit exists here because it's the same height, technically, and this is my favorite part, we don't know that. We don't know what infinity is. So this from the left might have continued on while the one from the right stopped. So the one from the left might be taller than the one from the right. So I don't know. I don't know what infinity is. So basically here, it does not exist. I know it's a little wacky, kind of neat. I think drawing it really helps. Alright, so let's scroll up and see if we met our learning goals. Students will be able to understand what an infinite limit is. Remember that basic definition, if our value, our height, our L approaches infinity or negative infinity, we have an infinite limit. I'll see you on the next video.